Hi again. We're on chapter 6, Markup and Markdown. We are going to use some of the number line diagrams and the little handy dandy chart that you've used before for percent change in this chapter. So go back to that if you still have some questions. But this chapter, we're talking about profits that a company would make on the merchandise that they sell. So, what's important here is that we need to ensure, the companies need to ensure that they are buying the products for less than what they're selling them for. Because in that difference, like on the number line, was the difference between not making any profit, making profit, or like losing money. So we don't want to do that. So we look at the markup or the increase over the price that the company paid for that actual product because we want to have a profit. So when we talk about markup, we look at operating expenses and any other type of overhead that might occur that will eat into the company's profit. So we're going to talk a few about those. And as we start, you can see the number line diagram, and we start with 0, and we have the cost of the goods sold. Is that first amount. Then the operating expenses. And then, of course, that break-even point where, you don't make any money, but you don't lose any money. It's right there in the middle. And then the net profit. And under that, the markup is including those operating expenses in there. Now, when we look at costs of merchandise, we want to remember that we're going to use, it'll be proportionate, markups will be proportionate, because you're not always going to want to have the same markup on all your items. So for example, as it says in the book, if a company buys pens and sells pens, they're not going to have as great of a markup on those pens as they would on like living room furniture. So we're going to look at two different possibilities to look at markup. It is not always which one is better. They are both used because different companies have different needs. So what we want to do is look at the a markup on cost or a markup on the selling price. So here's our little handy dandy diagram that we've used before. In this one, we're going to talk about cost plus the markup equaling the selling price. So the 100% will be placed to identify the base. So it could be next to the cost or the selling price, depending on what we're actually looking for. So let's get into the first example. A retailer purchases wicker baskets for $14 each and uses a 70% markup on cost. Find the retail price of these baskets. So we're doing a markup on cost. So we're putting the 100% by the cost, and that was the $14. Okay, because that's how much they are purchasing for. We also have a markup of 70. So when we add up those two lines, 100 plus 70 is 170%, right? And then we're going to want to do either looking at the formula the way it is down here, 170 times 14 divided by 100 is 23.80. So we know that the wicker baskets will sell for 23.80. Now I do have a little, let's see if I can find it, the way I like to set up proportions, and you can use the chart to do it. So I think in percent change, if you remember, it looked at, okay, what rows are we going to use? And for this example, we're going to use the first row and the third row because we know we're starting at 100%, going to 170. We know that the price of the baskets was 14, but we don't know, or it's X is our unknown factor of what the markup would be. So I put it in a proportion. 100 over 170 is equal to 14 over X. And then I just cross multiply, which is basically what's happening there in the book. But I like to set it up in that fashion because it just makes it easier for me to figure out the answer. Now, it's not asking for the markup in this question, the dollar amount, but you could find that out now because you can say 2380 minus 14, and you're going to get the markup on the baskets. Now we're going to talk about basketballs. And this company, All Sports, purchases basketballs at $23.97 each. They apply a markup on the selling price of 40% to cover their operating expenses. So we want to find the selling price of the basketballs. So we know that our 100 needs to go in the bottom because that's our base. And we know the markup is 40. So the cost line is going to be 100 minus 40, which is 60. So then we can do our multiplication. And it's either the cross multiplying like I did, or it's set up this way in the textbook. And we can see that the selling price of a basketball would be $39.95. So we are looking at percent increase problems, just basically like the ones we did before. So hopefully we can easily get through these assignments with this. Example 3, after a 75% markup, a cartoon character lunchbox sells for $12.95. What was the cost? So this is a markup on cost, and so the base is next to the cost, right? That's where the 100% comes in. And we know that we have the $12.95, so we can cross multiply again or just use the formula straight as it was. So the original cost of the retailer was $7.40. Again, you can find that markup. It's not asking you for it, but you can find it, and you can say $12.95 minus $7.40, and that's going to be the markup. That also will help you if you need to check your work. So another example, Coffee Beans wants to sell a coffee maker for $49.95 in order to meet a competitor's price. If they need a markup of 30% on selling price, what can they afford to pay for this coffee maker? So basically what we're looking at here is, there's different companies in town, and they basically could either, sell the same products, and, they want to see if they can compete and gain more customers. What we're looking at here is to see if it makes sense for us to do that, because we don't want to lose money on it. We know from this example that they had to have a 30% markup because that's what their overhead and everything else is in relation to the selling price. So can they actually do this? Does it make sense? So we set up the chart the same way. Our 100% is on the selling price. And so we would then obtain the cost percent of 70%. So that one would be $49.95 times 70 divided by 100. So the cost of the coffee maker to the retailer should be about $34.97. So basically then Coffee Beans could go out and find a supplier, and if they could find one that could sell them one for $34.97, then they can meet their price and retain the profit that they need to Doesn't always happen that way. That's not always the best way to compete. And if it doesn't work by monetarily spending less money, then finding other ways that a business can save money or make money. So example 5, a music store purchases an electric guitar for $450 and sells it for $799. What was the markup on the selling price? Okay, so the base 100% is in the selling price. We have the figures for $450 and $799, and we find out that the guitar was marked up by 43.68%. Again, we can find the markup dollar amount. We don't have to in this solution, but we can if you want to fill that out. It gives you practice. You can keep going on with that. So we've talked about before that, even though a number looks bigger, it might not always be the best option to go with. And that's what we're looking at here. It's what's the larger markup, 40% on cost or 35% on selling price. So basically, we're setting up these charts next to each other. And so we're going to compare, and we're going to do the problem for both and see what makes sense. In this case, we don't have to have the dollar amount because we're looking at the percentages to see where we would come up with the best price. So basically, we're filling that out using the multiplication that we had before, and we find that the 35% markup on the selling price is a larger dollar markup and then a larger selling price. So that's your section on markups. Now we talk about shrinkage. Shrinkage has to be included in this figuring out what our profit is going to be, because not only is overhead important, but shrinkage happens all the time. Now there's different types of shrinking. You could say shoplifting is a kind of shrinking, employee theft, spoilage, or breakage. So we use to anything that's an unsaleable merchandise, we call it shrinkage. It's also loss. So it means you don't have as many of the items for sale. And so you have to calculate what your profit's going to be based on that smaller number than you would have before. So we're going to have an adjustment or an adjustment cost. And we can set up our little chart again. We're looking at the cost, the adjustment, and the adjusted cost. So the adjustment is added to the cost to get the adjusted cost. So Kenny's discount store purchases calculators at a cost of $17.67 each. If Kenny typically experiences shrinkage of 7%, what is the amount of the adjusted cost and the adjustment due to shrinkage? And that's an important thing to think about too, is companies don't know for sure exactly what their shrinkage would be, but they probably have a pretty good idea based on the history, and that's why it's important to keep that history to know what on average is getting stolen more. And some companies go so far in stores to lock up some of the items that are the most likely to get stolen so they can try to reduce their shrinkage without losing a lot of additional money. So he's got 7%, and then we want to look at the adjusted cost. So we set up the markup diagram, and we find out that we're going to say the 100 minus the 7, which is going to give us the 93%. And we are looking at, he purchased them at $17.67 a piece. But how much does he have to account for shrinkage? So he has to adjust it up $1.33 to be able to cover that. And here's a good one. Hector's Produce buys bananas at $42 per 100 pounds, and he expects 15% to spoil. Hector needs a 20% markup on selling price to cover operating expenses. What should the selling price of the bananas be per pound? And it might be, you might want to just say 15 plus 20. No, we can't do that again. So we have to tack on. So the cost percent would be 85%. To find the adjusted cost, we use the proportions. So the adjusted cost of 100 pounds of bananas is approximately $49.41. So, but we're not quite done yet. We still need to do the markup on the selling price. And so based on that and putting our numbers into the calculation, we see that 100 pounds of bananas would sell for $61.76. We also could divide it by 100 because we want to find out the price of 1 pound, because usually individuals don't buy all 100 pounds of bananas. And then we would get the 62 cents. Okay, so we have an example of quantity decreases rather than percent decreases. So you have to look at that when it's asking you the problem. And this is one of those. Mirror Central purchases 36 mirrors for a total cost of $540. They all arrive, but 2 are broken when placing them on the shelf. The retailer needs an 80% markup on cost. What should the selling price of each mirror be? So originally, he or she spent a certain dollar amount on the 36 mirrors. He spent $540. But on $540, if we do the math on that, 540 divided by 36, originally each mirror was $15. But we broke 2. So now we have to take that $540 and divide it by 34 mirrors instead. And we get $15.88. So then we need to figure out the markup using the diagram. And we now find that we have to sell each mirror for $28.59. So sometimes the cost of shrinkage can be passed on to the customer. I kind of mentioned this a little bit before, but if the selling price is already nationally advertised or there's a pre-printed selling price, companies will have to decide what they're going to do and how they're going to be able to figure out how to, eat some of their loss and not have to pass it all along to the consumer when they think the selling price is $19.95, and based on the fact of your shrinkage, now you've got to charge them $24. So something to take into consideration. So now we have a bookstore at Spring River College, and they're going to sell sociology textbook for $129.95. That's a lot. They receive a 40% trade discount from their supplier, and their operating expenses are 25% of cost. They're going to expect 5% of shrinkage due to theft, because I guess people want to go in and get their books for free rather than having to pay for them. How much profit can the bookstore expect from the sale of this textbook? So we look at, there's a 40% trade discount. So we are looking at multiplying by the complement, which would be 60. And then we figure out the rest of our problem. And we can also put this down in one of our number line diagrams to see where everything would fall as well. So then we get the answers to that. So when we mark something down, we are going to use standard percent decrease problems. And we're going to look at, the first few are some typical markdown problems. Benson Office Furniture is offering 20% off of all merchandise. If a desk regularly sells for $350, what is the sale price? So to get the sale price, we use the complement again of 20%. So we get 80%, 350 times 80% or 0.80 gives us $280, which would be the sale price for the desk. This one uses the fraction instead of the decimal. Now you can use it either way. If you do use the fraction, you would need the complement of the fraction, which is 2/3, because 1/3 plus 2/3 is equal to 3/3 or a whole. If you were to use the fraction, we would be looking at 0.333 repeating, and 2/3 would be the 66.67%. So the sales price, when we figure that out, would be $93.30. So next we mark down a jewelry box from 95 to 80. We want to know the percent markdown so that the retailer can advertise, hey, this is dropped a certain percent. I mean, you can always say it was dropped $15, but looking to see what sounds better, what seems like it's more than the other. So we use the diagram again, and we find that a 15.79% markdown on the price can be advertised. Of course, like I said, we probably wouldn't want to say that. We probably would want to say approximately 15%, or go with the $15. But it just all depends on what the retailer would like to do, without lying to the customer, being honest with the customer, of course. So example 4, Valley Furnishings purchases a sofa for $570. They mark up 40% on the selling price. Then there's a store-wide sale of 15%. So we want to know the sale price of the sofa and the percent markup on the sale price that they finally got for the sale of their sofas. So there's a couple of steps. We do the complement of 40, which is 60, and we have 57 times the 100 in the bottom corner divided by the x over 60 if we wanted to do that way. Then we get 950. And then for the 15% off sale, we use the complement and we get 807.50. Okay. So, and then subtracting the dollar amounts, we found the final markup was $237.50. And then we compute the percent markup, which it ends up being about 29.41%. Another one, Fanny's Fragrant Fantasies. I love that. Purchases perfume from their supplier for $20 per bottle. They mark up the price 250% on the cost and later have a 60% sale. Operating expenses are 65%. Does Fanny's incur a net profit or an operating loss for a bottle sold at the sale price? And then we want to know how much. So that's when we put everything into our handy dandy little box again, and we find out as we go along. Oh, we have our little diagram as well. We see that the Fanny's Fragrant Fantasies will incur a $5 operating loss when they sell the perfume at a price $5 below their break-even point. So they really probably wouldn't want to do that. That wouldn't be a good business decision to make. A sporting goods store purchases an exercise machine for $169. They mark up the machine 75% on cost, and operating expenses are $40. What is the largest possible markdown they can offer without incurring any loss? So again, we set up our problem. We find out, we can also do the diagram, and then we find out that the sporting good store can offer a 20% markdown without incurring the loss. righty. I believe this is the last section of this chapter. Yes, it is. Sales tax. So we all know about taxes. We all know that we're taxed by the federal government, the state governments, and local governments, and they're trying to collect additional revenue to pass along to the consumers in other ways. So we are going to look at that and excise taxes on here. Most states do have sales tax. Some of us are lucky and don't. So we want to look at what it would be if we were to add it. So we are going to look at it's a percent increase problems by using the augmented percent. So remember the complement was the opposite. So if it was 60, you would say 100 minus 60 and get 40, and that would be the complement. The augmented percent is adding that 1 once you move the decimal point or times 100. So Rita purchases a child's board game for $15.95 plus $8.25 No, 8.25% sales tax. What is the total amount she must pay? So when we look at the sales tax, we would say $15.95, which is what the original price, times the 8.25% sales tax, which you would write as 1.0825, and you'll get a number approximately $17.27. What's really nice is that, those states that don't have that, it's easier to figure out if you're staying in budget because you're not having to add that sales tax increase, but you can still figure it out, but it just makes it a little bit easier. So on this example, we're looking at a bookstore that collected $14,287.55. That included purchases and sales tax. So we want to find out what the dollar amount was of the sales tax. Now this is really important because companies have to keep track of that. The company's profit is not $14,287.55. The profit is actually that subtracted by the 5.87% of the sales tax rate. So we need to keep that in consideration. Companies really need to keep that in a separate bucket because if they don't, they might find themselves using all of it and then go later on when taxes are due, go, where's that money? And they've already spent it and they shouldn't have because it's not, it belongs to the government. So we will set up a percent increase diagram. We put the 100 as the base, that's the old, and then we have the 5.875%. We do our little cross multiplying, and we find out that Norton's bookstore collected $792.82 in sales tax on Monday. We also have excise taxes on some items. Fuel has excess taxes. For example, 2018, pistols were taxed at 10%, gasoline at 18.4 cents per gallon. So it just depends. A lot of times the different governments will, in an attempt to reduce consumption, they will provide excise taxes on cigarettes and alcohol. All right. So Steve purchased 2 round-trip tickets from Kansas City to London for $1,018 each. But we know, that if we add $1,018, we only get $2,036. But we know there's taxes included, and we have to take that into consideration as well. It always seems so nice until you get to the additional taxes. But in this case, we needed to add an air transportation excise tax, an international air travel excise tax, and the sales tax. And so once we add all of those together, do the multiplication and add, we're going to get a total of $2,353.24, which is, a little bit above that 2,000. So you've got to take in consideration that extra amount. So then go ahead and do your Chapter 6 exercises. I hope this video rundown helped you. As usual, if you have any questions or you need my help, please do not hesitate to reach out and we can work on these. Thanks a lot. Until next time.